Welcome guys. Today let's go to release notes of Microsoft, and they announced in TypeScript 5.3 at 20th November 2023. Today they're excited to announce the release of TypeScript 5.3. If you're not familiar with TypeScript, it's a language that adds type syntax to JavaScript to bring type checking. Type checking can catch all sorts of issues like typos and forgetting to check for null and undefined. But types go beyond type checking. The same analysis of TypeScript's type checker are used for rich editor tooling, like autocompletion, code navigation, and refactorings. So I should say that autocompletion is must-have for front-end developers. If we have a good autocompletion, we can make a better developer experience. In fact, if you've been writing JavaScript in editors like Visual Studio Code or VS Code, that experience is powered by TypeScript. To get started using TypeScript, you can get it through npm or through npm with the following command. npm install -d TypeScript. It's a developer dependencies. Here's a quick list of what's new in TypeScript 5.3. So they have import attributes, stable support resolution mode in import types, resolution mode supported in all module modes, switch to narrowing, narrowing on comparisons to booleans, instance of narrowing through symbol has instance, checks for super property access on instance fields, interactive inlay hints for types, settings to prefer type auto imports, optimizations by skipping JSTOC parsing, optimizations by comparing non-normalized intersections, consolidation between test server library.js and TypeScript.js, breaking changes and correctness improvements. So what's new since the beta and RC? Since the release in the date, no major changes have taken place. Since the beta was released, we've added an option. They added an option to prefer type-only auto imports when possible. The beta permitted resolution mode to be used across models and resolution settings, but it's not documented. Import attributes. TypeScript 5.3 supports the latest updates to the import attributes proposal. One use case of import attributes is to provide information about the expected format of a model to the runtime. They only want this to be interpreted as JSON, not a runnable malicious JS file with a JSON extension. Import object from something.json with type.json. The contents of these attributes are not checked by TypeScript since they are host-specific and are simply left alone so that processing runtimes can handle them and possibly error. TypeScript is fine with this, but your browser probably not. So import all as foo from foo.js with type fluffy bunny. Dynamic import can also use import attributes through a second argument. Const object await import from something.json with type.json. The expected type of the second argument is defined by a type called import call options, which by default just expects a property called with. Note that import attributes are an evolution of an earlier proposal called import assertions, which we implemented in TypeScript 4.5. The most obvious difference is use of the with keyword over the assert keyword. But the less visible difference is that runtimes are now free to use attributes to guide the resolution and interpretation of import path, whereas import assertions could only assert some characteristics after loading a model. Over time, TypeScript will be deprecating the old syntax for import assertions in favor of the proposed syntax for import attributes. Existing code using assert should migrate towards the with keyword. New code that needs an import attribute should use with exclusively. They'd like to thank Alexander Tarasuk for implementing this proposal, and we'd also like to call out Menlu1 for the implementation of import assertions. They have a stable support resolution mode in import types. In TypeScript 4.7, TypeScript added to support for a resolution attribute, /reference types equal something, to control whether a specifier should be resolved via import or require semantics. So for example, they have reference types package, resolution mode require, or reference types package, resolution mode import. A corresponding field was added to import assertions on type-only imports as well. However, it was only supported in native versions of TypeScript. The rationale was that in-spirit import assertions were not intended to guide model resolution. So this feature was shipped experimentally in nightly only mode to get more feedback. But given that import attributes can guide resolution, and that we've seen reasonable use cases, TypeScript 5.3 now supports the resolution mode attribute for import type. Resolve package as if we were importing with a require. Import type from require from package with resolution mode require. And import type from import from package with resolution mode import. And after that, export interface merge type extends type from require and type from import. These import attributes can also be used on import function types. Import type from require, import type from import, function type from require, method from type from require, type from import, and after that export interface merge type extends type from require, same since type from import, and empty object. For more information, check out the change here. Resolution mode supported in all model modes. Previously, using resolution mode was only allowed under the model resolution options, Node 16 and Node Next, to make it easier to look up models specifically for type purposes. Resolution mode now works appropriately in all other model resolution options, like Bundler, Node 10, and Slipper doesn't error under Classic. For more information, see the implementing pull request. Switch to narrowing. TypeScript 5.3 now can perform narrowing based on conditions in each case goes within a switch true. So for example, if we have function with unknown types, we can simply do switch true, case type of x string do something, case array do something, and default. This feature was spearheaded in short work by Maciej Bruzinski. We'd like to extend a thank you for this contribution. Narrowing on comparisons to booleans. Occasionally, you may find yourself performing a direct comparison with true or false in a condition. Usually these are necessary comparisons, but you might prefer it is a point of style or to avoid certain issues around JavaScript truthfulness. Regardless, previously TypeScript just didn't recognize such forms when performing narrowing. TypeScript 5.3 now keeps up and understands these expressions when narrowing variables. Interface A, interface B, A string, A B type string, type my type intersection of A and B, and we have function is A. X my type, x is A, return A and X. Function some function, x my type, if is A equal true, console.log x and A, and it works. We'd like to thank Mateusz Bruzinski for the pull request that implemented this. Also, they have instance of narrowing through, symbol has instance. A slightly esoteric feature of JS is that it is possible to write the behavior of the instance of operator. To do so, the value on the right side of the instance of operator needs to have a specific method named by symbol that has the instance. If we have class video with static symbol as instance test value, and if we return tested value equal to undefined, they should return false if console log with new instance of weirdo, and they should return true if console log undefined instance of weirdo. To better model this behavior in instance of TypeScript, now checks if such a symbol as instance method exists and is declared as a type predicate function. If it does, the tested value on the left side of the instance of operator will be narrowed appropriately by the type predicate. So if we have an interface point like with x number and y number, class point implements point like x and y same, constructor x and y number, this x equal x, this if we have interface point like with x and y, and x's number and y's number, and class point implements point like with x and I the same, and constructor the same, simple feature. And this is from origin some math, and if we have static symbol as instance with value unknown and the value is point like, we should return not val and type of val equal object, and string x in value and string x in val and type of val that x number and type of val that y equal number. And we have function f is value unknown, and if value instance of point can access both of this correct, and value of x and value of y can't access this. We have a point like, but we don't actually have a point, and value distance from origin, and we can call this method from the value because it's instance of point of this class. As you can see in this example, point defines its own symbol as instance method. It actually acts as a custom type card or a separate type called point type. In function f, we were able to narrow value down to a point type with instance of, but not a point. That means that we can access the properties x and y, but not the method distance from origin. We can access properties, but we can't access methods. That's cool. Checks for super property access on instance fields. In JS, it is possible to access a declaration in a base class through this super keyword. If we have class base with some method and class derived extends base with some method, some logic, and super call some method of base, and you derived some method prints two logics, this one and this one. This is different from writing something like this some method, since that could invoke an overridden method. This is subtle distinction made more subtle by the fact that often the two can be interchangeable if a declaration is not overridden at all. We have class base with some method, class derived extends base, some other method. This some method should call on derived code, and super should call on base. And this call derived don't have this, and it's called from base because new derived some other method twice calls base logic console.log some method called. The problem with using them interchangeably is that super only works on members declared on super type, not instance properties. That means that if we wrote super sum method, but sum method was defined as a field, you'd get a runtime error. Sum method, error function, some logic, class derived extends base, some other method, and super dot some method. And you derive that some other method calls error doesn't work because super dot some method is undefined. TypeScript 5.3 more closely inspects super property accesses method calls to see if they correspond to class fields. If they do, we'll now get a type checking error. This check was contributed since the check works. Interactive lay hints for types. TypeScript's lay hints now support jumper to the definition of types. This makes it easier to casually navigate your code. They added a simple video. Let's watch it. Interface point. Go to type declaration. Interface declaration. Yeah, that's cool. Settings to prefer type out the inverse. Previously, when TypeScript generate out the inverse for something in a type position, it would add a type modifier based on your settings. For example, when getting an auto import on person in the format export let p with type person. TypeScript editing experience would usually add an import for person as an import person from types export let p with type person. And under certain settings like abbreviation model syntax, it would add the type modifier import type person from types export let p from person with type person. However, maybe your code base isn't able to use some of these options, or you just have a preference for explicit type imports when possible. This interesting change to now enables this to be an editor-specific option. In Visual Studio Code, you can enable it in the UI under TypeScript preference, prefer type only auto imports, or as the JSON configuration option. TypeScript preferences prefer type only auto imports. Optimization by skipping JS.parser. When running TypeScript via TSC, via TSC, the compiler will not avoid parsing JSTOC. This draws parsing time on its own, but also reduces memory usage to store comments, along with time spent in garbage collection. All in all, you should see slightly faster compiles and quicker feedback in double dash watch mode. The specific changes can be viewed here. Because not every tool using TypeScript will need to store JSTOC, e.g. TypeScript is the interpreter, this parsing strategy has been surfaced as part of the API itself. This can enable these tools to gain the same memory and speed improvements we've brought to the TypeScript compiler. The new options for comment parsing strategy are described in JSTOC parsing mode. More information is available on this pull request. Optimizations by comparing non-normalized intersections. In TypeScript, unions and intersections always follow a specific form, where intersections can contain union types. That means that we create an intersection of a union-like, for example, a intersection of union of B and C. That intersection will be normalized into union of intersection of A and B and intersection of A and C. Still, in some cases, the type system will maintain the original form for display purposes. It turns out that the original form can be used for some clever fast path comparisons between types. So, for example, let's say we have some type intersection and union of type 1 and type 2 and type infinity, and we wanted to see if that's assignable to some type. Recall that we don't really have an intersection as our source type. We have a union that looks like some type intersection of type 1, union of intersection of some type and subtype 2, and so on. When checking if a union is assignable to some target type, we have to check if every member of the union is assignable to the target type, and that can be very slow. In TypeScript 5.3, we pick as the original intersection from that we were able to tuck away. When we compare the types, we do a quick check to see if the target exists in any constituent of the source intersection. And for more information, see this pull request. They make optimizations for comparing every member of the union is assignable to the target type. And the consolidation between the server library.js and TypeScript.js. The script itself ships two library files, the server library.js and TypeScript.js. There are certain APIs available only in the server library.js, like the project service API, which may be useful to some projects. Still, the two are distant bundles with a lot of overlap, duplicating code in the package. What's more, it can be challenging to consistently use one over the other due to auto inputs or muscle memory. Accidentally loading both models is far too easy, and code may not work properly on a different instance of the API. Even if it does work, loading a second bundle increases resource usage. Given this, we've decided to consolidate the two TypeScript.js now contains food server library.js used to contain and server library.js now simply re-exports TypeScript.js. Comparing the before-after of this consolidation results the following reduction in package size. And packed and unpacked before and after. Difference percent. It's a lot. 20%, 21%, 100%. But TypeScript.js and TypeScript.js was 40 and 7%. It's okay. It's good. In other words, this is over a 20.5% reduction in package size. And the last one, breaking changes and correctness improvements. libTTS changes types generated for the DOM may have an impact on your code base. For more information, see the DOM dates. I recommend to proceed to this link. Checks for super access on instance properties. The 5.3 now detects when the declaration referenced by a zipper property access is a class field and issues an error. This prevents errors that might occur at runtime. And what's next? While our iteration plan isn't yet public, we are already working on TypeScript 5.4. They expect that TypeScript 5.4 will have a stable release towards the end of February 2024. Anticipate more details to come here. Until then, they hope you can start using TypeScript 5.3 soon, and that it makes your day-to-day coding a joy. And happy hacking. The article made by Daniel Rosenwasser and the script team. So let's go proceed to the document for TypeScript 5.3. What they do? Very small set of updates, couple of new roles and couple of new properties in RTC. Let's go to files changes. Files changed. What they do? They add mid string, traffic identifier string, export key from key format key, cryptic key from storage buffer JSON web key, generated key algorithm, extractable promise crypto key pair, export key algorithm, promise storage buffer JSON web key, and the user should not address in verify promise crypto key pair. It's CRC we don't generate DTS. Believe the worker generates DTS too fast. It's not critical, but important. So thanks for watching. Bye.